First things first, I need to determine the states of things. HF is a weak acid, so I'm going to show aqueous on that. KOH, because of the K, is going to be dissolved in water. H2O, water in water, is going to be a liquid. And then because of the potassium, I know this is going to be soluble in water. Now, dissociating, here's the deal. Acids dissociate, but only if they are strong acids. Do I actually show them as dissociated? So what that means is that this HF doesn't dissociate fully, so I'm going to leave it alone. I'm going to come over here. The K and the OH will dissociate because that is fully soluble in water. I'm going to leave the H2O alone. It does not dissociate, but the KF does. Now, I got to eliminate spectators if I'm going to write a net ionic equation. The H and the F are off limits because they did not dissociate, so I'm going to leave the H's and F's over here alone. I am going to go over here, though, and I notice that the K is dissociated on both sides of the equation. It is a spectator, so I can cross it out, and then I can rewrite the equation without the K's, basically. Now, you may be wondering, why are you leaving the OH alone? Well, the simple reason is that the OH became part of the water over here. So the OH is participating in this reaction. It's not a spectator. So I'm going to rewrite this as HF aqueous plus, now the K is a spectator, we eliminated it, so it's just OH minus yields H2O is a liquid and F minus, which is aqueous, just like that. And there's your net ionic. So, if you were asked to draw this, well, first things first, you would show the HF coming in as one particle. You would show the OH as a particle in here. I don't know why I wrote that, but OH minus, just like that. And then you would show the K's just floating around by themselves. Because they're spectators, they're not reacting with anything. So you have an HF, which is not dissociated, and then you have the K and the OH being shown as dissociated from each other. Coming over here on the product side, you're going to get a water from this reaction right there. And then you're also going to get KF, but you're going to show that as dissociated. So K plus and F minus. So when you draw a particle level diagram like this, it actually lets you see why we eliminate certain things really easily. You'll notice that the HF doesn't exist anymore on this side. It turned into F. You'll notice the OH doesn't exist anymore. It became H2O. The thing that didn't change is the K plus, which is why we eliminate them when we write the net ionic equation.